Okay, section 4D is loan payments, credit cards, and mortgages. It's essentially one formula. It's the payment formula that we see below. And PMT will represent payment. This would be some sort of installment payment, a regular amount, so the same amount each time a payment is made, over maybe a weekly payment, monthly payment, annual payment. Typically we'll see monthly. So the other parts of the formula are pretty well known. P is the principal, in other words, the amount that we borrow for the loan, or the initial amount of the loan. R is the rate, percentage. We'll always convert the percentage to a decimal. N is the number of times per year that payments are made. So if it's a monthly payment, N is equal to 12. Weekly payment, N is 52, so on. And T is the time in years. Just as always, it's got to be in years over which the term of the loan. So let's use this fairly complicated formula. One thing I would suggest as you work on it is to use parentheses, notably here, and even in this exponent. If you plug these numbers into your calculator, anywhere you see a parenthesis in this formula, it's good to put parentheses in your calculator as well. So I'll try to show the calculations of this when we work on problems so you'll know what to do. Okay, so to try an example. Suppose we take out a loan of $5,000 at an interest rate of 8%. The term of the loan is 5 years to be paid back monthly. Calculate the monthly payment for this loan, and then calculate the total cost of the loan. So two things to do. First, we need to find the monthly payment, right? They're asking for the payment of this loan. So we know right away that this is the payment formula. And then if we remember it, good. We know it's the principal times R over N, all divided by 1 minus 1 plus R over N to the negative NT. And I'll use parentheses around that negative NT to make sure I do that right when I plug it into the calculator. So we should identify the parts of the formula that we know. We know that the principal of this loan, well, it looks like we're taking out a loan of $5,000. So principal P is 5,000. Next, the term of the loan, 5 years, so T is 5 years. We're always going to have T in terms of years. It's already given in years, so we're all set. The loan's going to be paid back monthly. Okay, so that means that N is the number of times per year we make a payment, so N is 12. So N also be the number of times per year that interest is compounded against the balance of the loan. We'll talk about that a little later. Now we know N, T, and P. The last thing we need to find is R. And if we look in the problem, that's 8%. So we'll convert that 8% to a decimal by moving that decimal place always 2 places to the left for percent to decimal conversion. Okay, so the next step is to plug all this stuff into our formula. If we can make some simplifications, we'll do that. If not, let's just learn how to plug things into calculators carefully. We'll be all set. Principal is $5,000 up top. It's also a nice step to show in work if that was ever going to be the case. 0.08 over N is 12. And we have 1 minus 1 plus 0.08 over 12 for N to the negative N times T. So this is to the negative 12 times the term of the loan is 5. And parentheses closed on the bottom. So here we are, or bracket closed on the bottom. So I can simplify one part of this right here. So I'll go ahead and do that. The same way that it would simplify for the savings account formulas that we've seen. It's not necessary to do so, but it just makes plugging things into the calculator a little easier maybe. 0.08 over 12. And we've got 1 minus 1 plus here's the simplification. 12.08 over 12 to the negative 60, it looks like, and then close parentheses. Okay, so now this thing is a little bit more ready for the calculator. So let's go ahead and take it to that. So switching screens, let's go to a calculator. And what did we have? Let's clear this. We had 5,000 times, we don't have to be so careful with the top, the rate was 0.08 divided by 12. And let's see, now we're going to divide that by everything in that denominator. We should be careful with parentheses. We have 1 minus parentheses 1. Well, I simplified that, so I'm just going to put 1 or 12.08 divided by 12. That was the number that we had here earlier. So this is all raised to the power of negative 60. And we'll close that parenthesis in the bottom. And it looks like we have $101.38. So let's go back and write that down. 101.38. So 101. This is approximate, of course. We rounded that decimal, so we'll write it as $101.38. And we use standard rounding. We didn't have to change that 8 because the number next to it was less than 5. So there's our payment for this loan. Okay? So maybe I'll summarize that here. The payment is $101.38. Now the next question that they ask in this problem is calculate the total cost of the loan. Okay, so the total cost of the loan, well, that's just the sum of all the payments. All right, so the total cost, here's a formula to find that. Total cost of the loan is always going to be equal to payment times the number of times per year payment is made, which is N, times the number of years the loan goes on, which is T. So in our case, this is 101.38 times 12 times T. T is 5. And, well, we'll plug that into a calculator shortly. So let's go to a calculator and do that. Since we've rounded, I'll go ahead to the next line and try 101.38, our rounded value, times 12 times 5. And we've got 6,082 and 80 cents. So I'll write that down as our sum of payments, or our total payments. That was 6,082 and 80 cents. Okay, so the next question that one might ask, we're not asked here to do so, but another problem might ask you to find the total interest paid on the loan. So the total interest paid is easily found once we have the total cost of the loan. Total interest equals total cost. Whatever isn't principal is interest. So total cost of the loan minus the principal, and that'll be our total interest. Okay, so what we end up with is 6,082.80 minus $5,000 was our principal. And usually this calculation is pretty straightforward. We have $1,082.80. Okay, so there we go. That would be our total interest paid on the loan. Nice calculation to have, because then you can compare this loan to another loan with different terms or different interest rate or so forth. Now, one thing you want to check when you come up with these calculations, it's nice to look at the total cost of the loan, which was here, because then you can compare that to the principal that you started with here, $5,000, and say, okay, it should be more, but it shouldn't be astronomically more. That way you don't make mistakes with this. It should certainly not be less. So anyway, that's the payment calculation for now. Let's see what we can do with it next. So part B of this question, determine how long it will take you to save up the $5,000 rather than take out a loan by putting away a monthly payment amount equal to that of the monthly payment of the loan. And then we'll calculate the total cost of this scenario. So we're going to save up $5,000 by putting away a monthly amount equal to that of the monthly payment of the loan. So our goal is to get to $5,000 total. So we don't want to borrow money now. It's just different strategies for coming up with this cash. $5,000. Okay. How long will it take, or how many months will it take to save up $5,000 if we're going to put away our monthly payment amount of $101.38 per month. Okay, well this will tell us how many months, right? This is dollars per month. We're dividing by it, so we're going to be left with a unit of months. So anyway, let's see what that looks like. Go into a calculator again. 5,000 divided by 101.38, and that's 49.32 months, we'll say. So we'll fix that in a minute. 49.32 months. 49.32 months. Well, if we're in a situation where we want to make sure we have at least $5,000, which we'll always assume is the case, we should probably round this up to the next nearest whole month. So we'll say 50 months. That way we don't have to come up with an extra surge of cash in the last month to meet our target in month 49. 50 months is how many years? Well, we could do a conversion there, but 48 months is 4 years. So this is 4 years. And then 2 months left over leaves us with 4 years and 2 months. Okay, so that's how long that would take. Okay, that's the amount of time it would take. The next question they ask, the total cost in this scenario. Well, we save up to exactly $5,000, so total cost, well, there's no interest, there's no financing charges. So our total cost in this scenario is just what it takes to come up with $5,000. Now it's a pretty straightforward calculation. Okay, part C says, suppose you'd like to pay off this 5-year loan early, in 2 years perhaps. Determine what your monthly payment would be to pay this loan back in full in 2 years, and then calculate the total cost of the loan in this scenario. Well, this isn't too different from the first part of the problem. So our payment, instead of paying this thing off in 5 years, we want to know what the payment amount should be, regular payment amounts, for 2 years. We just use the payment formula again. So go to payment. To write that down, again, you might have to look it up. I happen to remember it. P times R over N. I'm just starting from the beginning, but we're just essentially changing the terms of the loan. 1 minus 1 plus R over N to the negative NT. Oops, that parenthesis here should be outside. These are mistakes to look out for, right? Here, and that should be outside, not the whole thing. So now we're ready to fill this in. Our principal's still the same $5,000 times R over N. Now they haven't changed the interest rate, so that's still 0.08. Remember, this was all in the beginning of this problem. We're doing the last part C of this multi-part problem. So $5,000 is the principal. 0.08 over 12, monthly payments for 12, and then we've got 1 minus 1 plus 0.08 over 12. Nothing has changed here except now we have negative 12, and not times t equals 5, but times t equals 2. Okay, so to kind of lay that out again, this would have been t equals 5. That's the old payment, the old version, and t equals 2. This is the one we want for this problem. Okay, so this will tell us what our new monthly payment is, if we want to pay it back in 2 years. So we'll plug it into a calculator and get a value. So let's switch over, and I'll do it all from scratch again just to practice one more time. We know we have 5,000. We enter here times 0.08 divided by 12. Again, we don't have to be careful with the numerator. It can look just like that, maybe a little different in a TI-30 or something like that. Now we divide by the denominator, which we should have parentheses around. This is 1 minus parentheses 1 plus 0.08 over 12. I didn't do the simplification trick that time. It's not always necessary. Raise this to the power of negative 12 times, oops, we want that to stay up there. We want to stay negative 12 times negative 12 times, there we go, 2 years, parentheses, close the parentheses in the denominator, and it should look something like this. 226.14, so 226.14 is what we'll round to. Let's go write that down. 226.14 $2.14 is our new monthly payment if we want to pay it back in 2 years. Now it's less than half the time of the original loan for 5 years, and it's a little bit over double. These linear relationships shouldn't hold like that, but this should kind of make sense in terms of these payment amounts. They should sort of match up. We should have to pay more per month to pay it back in 2 years versus 5 years. The last part of this question is to calculate the total cost of the loan in this format, so paying it back in 2 years. So remember, the total cost is sum of payments, which is, well, basically it's payment times N times T. Well, our payment is new. It's different now. We have $226.14 times N is 12 still, monthly payments, times T is 2 years, and we'll have to get a value from the calculator here in just a moment. So we'll switch. And 226.14 times 12 months in a year times 2 years, we're going to carry it out, $5,427.36. Okay, so this is reasonable, and we'll talk about why. So $5,000, and I've forgotten it. Let's go back and find it again. This is not unusual. It's just like being in class. $427.36. Thanks. 5,427.36. Good. Okay, so we've got our number written down. So that's the total cost of the loan. In other words, that's all the balance, or all the principal payments and all the interest payments summed up together by the end of the loan. One thing that we might calculate next, like we did before, was what's the total interest in this case? And what we should expect is that we would pay less in interest for a 2-year term than a 5-year term. So remember, total interest is total cost minus the principal, and in our case that's $5,427.36 minus 5,000, and I'll have to do a little trick to give us some room here, but that will be pretty clearly $427.36, which is substantially less interest than the 5-year scenario that we calculated before. Remember, the 5-year scenario compared to this number was this number, $1,082.80. So we almost cut our interest in half. Again, these linear rules don't work out exactly, but as a rule of thumb, we can kind of check this. We pay less interest for having the loan for less time. So our answer makes sense, and we should feel pretty confident about it. Okay, so one last question we should look at. It's asked us to calculate the amount of interest paid in the first of the loan in Part A, and the first payment of the loan in Part A of the previous example. Okay, so of these two parts of this problem, this first one's a little bit more important than the second. So at any point in a loan, the interest that's due is given by the interest formula. So we can look at it like this. The interest formula, even though it is the simple interest formula, this is the correct one to use. We just have to keep one thing in mind. Okay? On the first payment, the principal of the loan is still $5,000. We haven't paid anything down yet. Okay? Each one of our payments is applied to a new principal. So a little bit more of our payment goes towards the principal with every payment that we pay. And by the time we're done paying this loan off, our last payment has more principal than interest in it, versus our first payment should have more interest than principal probably, but we're going to find out shortly. Our rate again is 0.08, okay, and time t, well, how long has gone by before we're due the first payment on this loan? Well, it's monthly payment, so 1 month has gone by. So 1 month is what we would write down. But we can't plug 1 month into these formulas. We'll never do that, so we need to convert it. In 1 year, there are 12 months, so there's my conversion factor. Months cancel, I have years. 1 times 1 over 12, I have 1/12 year. Okay, so the interest that's due in month 1 is equal to the principal. Well, that's 5,000 because we haven't made any payments yet to make that principal lower, times the rate of 0.08 times the time of 1/12. And let's see, we need to go to a calculator for this one more time. That's 5,000 times 0.08 divided by 12. And that'll do it. $33.33. We'll round to that. Sounds good. $33.33 is our interest in that first month. Okay, so our payments for these loans and just the principal and interest payments on a mortgage are exactly that. There's only principal and only interest in each payment. So how much of our first payment was interest? How much was principal? Well, if our interest is $33.33 given right here. However, our principal we could find just by saying, well, the payment is interest plus, principal amount in loan in payment 1, right? So this is payment 1. It's the interest amount in payment 1 and the principal amount in payment 1. Well, we know that payment 1, this is equivalent to this situation, 101.38, our payment that we had before. It's equal to interest, which is 33.33. And the question's not asking us to do this. I'm just taking it a little further. Whatever's left over is the principal. Well, the principal, in this case, we don't know. It's P1, but we can solve for it. And P1 will be $101.38 minus $33.33. So I see 5 cents left over. Let's knock off 3 of 98, $68.35 it looks like. 68.35 is our principal. Okay, so we should see that change as time goes on. Maybe our second payment, the interest would be about $32 possibly, and principal would be about $70. And we just keep with each payment as the principal gets lower and lower, we keep shifting this interest amount to be smaller and the principal amount to be larger, especially with something like a home loan, which might last 30 years or 15 years, something like that. So the second part of this problem, calculate the amount of interest paid in the last payment of the loan in Part A of this example, or of the previous example. Well, this one's quite a bit more complicated, and we really don't need it. I might post a video later on it, but what you're going to find is that if you use an amortization calculator for a loan like this, you can just look it up approximately to see how much interest is paid on the very last payment of a loan. An amortization schedule breaks down every single payment over the entire life of a loan, whether it's 60 payments or 360 payments, and it tells you how each payment breaks down in terms of principal and interest. So maybe an amortization calculator. Lots of these are online. They're mostly free. Find a free one, find a nice one, and you can do a lot of work with this. Amortization calculator is the best way to go here. So there are ways to do it, but they're not really that important. So, okay, well, go practice these problems, and good luck with the work.